Okay, so let's continue with more exercises for this subtopic. So you are given a manometer which consists of mercury. One end is open, which is exposed to atmospheric pressure. Another one is connected to gas supply, which means that it experiences pressure from the gas. Okay, so you have learned in 2.1 that at the same horizontal level, the pressure is the same. So at A here, okay, pressure at A is equals to pressure at B because A and B is at the same level. Okay, so similarly at C and also at B, since C and B is at the same level, so the pressure is the same. Okay, so let's continue with more exercises for this subtopic. So as you have learned in 2.1, you are given a manometer. So pressure of liquid at the same level here, let's say here A and B. Okay, so at the same level, the pressure is the same. So here, one end is open, another end is also open. So both are experiencing the same pressure, which is atmospheric pressure. So at A and B, the pressure is the same. Okay, what happens if we have a manometer which the level of liquid is not the same? For example, this one. So one end is open and exposed to atmospheric pressure. Another one is connected to gas supply, which means that here it experiences gas pressure. Okay, so similarly, at the same level, they should have the same pressure. Okay, so let's say here at A, let's say here I'm labeling it with D. So pressure at A is equals to pressure at D. But if the question asks you to find the pressure of gas, we need to find a level which is the same as the level of the mercury. Here, the level of gas here at D, okay, means that B experiences gas pressure. So we need to find the same level at mercury here, which is C. Okay, so C here experiences the same pressure as B. So P gas is equals to PB, or PB is actually equals to PC. Okay, so at PC here, C experiences pressure from the atmosphere, which is PATM, plus the pressure due to the weight of the column above it. Okay, so the column above C pressure due to column C. Okay, so to find the gas pressure, it is equals to pressure at C, which is atmospheric pressure, plus pressure due to column AC. Okay, let's do one exercise. Example 1, figure shows a manometer containing mercury which is connected to a gas supply. Calculate the pressure at point A, B and D in unit of Pascal. Okay, so first we need to find pressure at point A. So pressure at point A is an open end, which means it is exposed to atmospheric pressure. So this one is simple. Atmospheric pressure is 76 centimeter mercury. Okay, so the question wants the unit in Pascal, so you have to convert to Pascal. So to convert to Pascal, you need to use formula rho GH. Rho is the density of liquid, G is the gravitational acceleration, and H is the height. So density of mercury is 1.36 times 10 to the power of 4. Gravitational acceleration 9.8. And height is just 76 here. Oops. 76 centimeter here. So the answer is 1.01 times 10 to the power of 5 Pascal. Next, to find the pressure at point B, from the diagram you can see that B is at the same level with C. Okay, B is at the same level as C, so the pressure at B is equal to pressure at C, and C experiences pressure from the gas, so PC is actually pressure from the gas. Okay, so PB is equals to atmospheric pressure, okay, atmospheric pressure here, plus pressure due to column AB. Okay. Okay, so atmospheric pressure in terms of mercury is 76 centimeter mercury, plus, you can just take the value, plus pressure due to column AB. So find the length of column AB, which is 18 minus 8, and you will get 86. So pressure at B is 86 centimeter Hg. Next, you have to convert to Pascal. So similarly, just substitute in formula rho, G, and H. So rho is 1.36 times 10 to the power of 4, G 9.8, and H is 86. And then you will get 1.15 times 10 to the power of 5 Pascal. Okay, next, pressure at D. Okay, so D, the height of column, mercury column, from A to D is 18. So pressure at D is equals to atmospheric pressure plus pressure due to column AD. So atmospheric pressure is 76. Pressure due to column AD, so the height is 18. You will get 94 centimeter Hg. Substitute in formula rho GH, and you will get 1.25 times 10 to the power of 5 Pascal. Okay, so next exercise. So figure shows an instrument for measuring atmospheric pressure. Determine the pressure at point X in unit of centimeter mercury. Okay, so from the diagram you can see that here above the mercury column is vacuum. Okay, vacuum means there is no air trapped and no pressure. Okay, no particles and so on lah. Okay, so number 1, to determine the pressure at point X. So X here experiences atmospheric pressure. So pressure at X is equal to atmospheric pressure, which is 76 centimeter Hg. Okay, so the question doesn't ask you to convert to Pascal, so you leave the answer in centimeter mercury. Next, number 2, calculate the pressure at point Y in unit of centimeter Hg. So pressure at Y is equals to pressure ATM, atmospheric pressure, plus pressure due to the column of X and Y. Okay, here. So atmospheric pressure 76 plus pressure at X and Y, 76 plus 8. So you will get 84 centimeter Hg. So if the question asks you to convert to Pascal, just use the formula pressure equals to rho GH. Okay, last question. Okay, so what happens if you have a mercury barometer with trapped air inside the column? Okay, so in the previous diagram, you have vacuum. But what happens if you have air instead of vacuum? So when you have air, it means that the air has pressure. It exerts pressure, air pressure on the mercury. So you can translate this diagram like this. Okay, so let's say, okay, this is mercury. Okay, so here open end is exposed to atmospheric pressure, and here this is the trapped air. So pressure of air trapped. Okay, so to find the pressure of air trapped, you need to determine the difference in the level of mercury first. Okay, change to red. Okay, so the difference here is 40 centimeter. Okay, so now I will label here A and here is B. So to find pressure of air trap, so you know that at the same level, okay, here atmospheric pressure is equal to the pressure at A. But what about B? Since B is above A, so pressure at B is actually pressure at A minus the height. Okay, minus the difference in height of the column. Okay, so pressure at A is 76 centimeter mercury because it is the same level as atmospheric pressure, minus height 40 centimeter, and you will get 36 centimeter mercury. Okay, so if the question asks you to convert, then you just convert to Pascal using the same formula, P equals to rho GH. Okay, so pressure of mercury 1.36 times 10 to the power of 4 times gravitational acceleration 9.81 times height of mercury, it should be in meter, 0.36. So you will get 48029 Pascal, or in standard form 4.80 times 10 to the power of 4 Pascal.